Hey guys, it's Mrs. Bothers, and in this video, we're going to look at two things. We're going to look at how to find distance between 2 points on the coordinate plane, and we're also going to look at drawing polygons on the coordinate plane. Okay, so here we go. If you're finding the distance between 2 points on the coordinate plane, there are two ways that you can do it. You can either count the spaces, which in my opinion is going to be the easiest way, and that's often how I do it. So in other words, if I gave you these 2 points right here, say -2, 5 and 4, 5. If I asked you how far apart those are, what's the distance between those two, one way you can do it, like I said, is just count the spaces in between. And normally on your graph paper, you're going to see all the grid lines. I don't have that here, but if I counted all the spaces in between, I've got 1, 2, 3, 4, 5, 6. I can see, in fact, let me draw that out for you since the grid lines are not here. I wish I had graph paper, but it's all at school. All right, so that's a total of 6 spaces. So from here to here, that distance is 6. And I'll put, we'll say 6 units because it doesn't give me an exact unit of measurement. All right, or if I wanted the distance between these 2 points, I have 4, 5 and 4, 1. If I count the spaces, it's 1, 2, 3, 4. Okay, so that's 4 units in between. So one method you can use again is just count the spaces in between. Okay, or there's another method that you can use, and that's it depends on, you can either add or subtract, and it depends on whether or not the points are in the same quadrant. Okay, remember the quadrants are the 4 open sections of your coordinate plane. And as we said last week, this section right here where everything is positive, and you learned this in elementary school, it was the first section you learned, so that is quadrant 1. And it goes counterclockwise, or it makes a C shape. It goes quadrant 1, 2, 3, and 4. So let me actually include those labels. So this is quadrant 1, 2, 3, and 4. You'll often see it written in Roman numerals like that. So just again, no 1, 2, 3, and that's 4. Okay. So the other method besides just counting the spaces is if you have 2 points that are in different quadrants, like I have here. See, this one's in quadrant 1 and this one's in quadrant 2. Another method that you can use is add the absolute values of the coordinates that are different. Okay. So if I look at these 2 points, I notice they have the same y coordinate. Okay, they both have 5 as the y coordinate. So that's not what's different. If I look at the numbers that are different, it's the x coordinates. I have a -2 and a 4. Well, what I can do is add their absolute values. So the absolute values are 2 and 4. So if I add 2 plus 4, that gives me 6. So I know that those are 6 units away. Or if the 2 points are in the same quadrant, like these two are both in quadrant 1, what I could do is subtract the value of the coordinates that are different. So in this case, these both have the same x coordinate of 4, but their y coordinates are different, 5 and 1. So I would subtract those, and that gives me 4. All right, so I'll look at a couple more things like that. So let's see, let me give you this point right here. Okay, first I want you to look at that. That's point. You're going across 1, up 1. I couldn't miss that. Anyway. All right, so anyway, if that's 0.11 and I ask you how far that is from 4, 1, again, there's 2 ways you can do it. I can count the spaces in between, okay, and that's going to be 1, 2, 3 spaces. Or since these are in the same quadrant, look at the coordinate that's different, which is an x coordinate, 1 and 4, and I would subtract, and that gives me 3. So I know that those are 3 units apart. Okay, what if I had a point down here, let's say right here, I'm going across -2 down to -4, and I want you to figure out how far -2, 4 is from -2, 5. Okay, if you need to pause for a minute, then do that because you can count the spaces, or if you don't count the spaces, since these are in different quadrants, what we would do is add the absolute value of the coordinates that are different. So if I look at these, they both have the same x coordinate of -2. The coordinates that are different are 5 and -4. If I add those absolute values, I get 5 plus 4, which is 9. So I know that these are 9 units away from each other. All right, let's look at 3 more examples here. Let's say I gave you these 2 points and I didn't give you a graph. Okay, well, one thing you could always do is you could always draw yourself a graph if you needed to, plot the points and then count the spaces, but that's a little more complicated. So if you're not given a graph, you want to use that second method of either adding or subtracting. Okay, to do that though, I need to figure out if these are in the same quadrant or different quadrants. Well, both of these points have only positive coordinates. So I know they're both in quadrant 1. All right, so since they're in the same quadrant, it means I'm going to subtract the values of the coordinates that are different. So the 6's are not different. The x coordinates are not different. So the y coordinates are different. 5 minus 2 means that those are 3 units apart. Okay? All right, the second pair of coordinates, -3, 1, and 5, 1. All right, I can see that these are in different quadrants. Okay? And so if they're in different quadrants, what I would do is add the absolute values of the coordinates that are different. So in this case, it's the x coordinates. So the absolute values would be 3 and 5. So that means that these 2 points would be 8 units apart. All right, and then the third pair of coordinates, these are in different quadrants. Okay, and that's because this has 2 negatives and this has 1 positive and then 1 negative. So I know that they're in different quadrants because the signs are not the same. All right, so since they're in different quadrants, what I would do is look for the coordinates that are different, not the y's, those are the same. So it's the x values. So I would add their absolute values, 4 plus 1, so that gives me 5. So those are 5 units apart. Now on your IXL that you're going to do, I believe it gives you the actual graph for every one of those, but it's good to know both methods. Okay, another quick standard I want to look at is polygons on the coordinate plane. We know a polygon is any shape, it's a closed figure that is only made of straight lines. It can't have any curves. So a circle is not a polygon, but a triangle, a quadrilateral, including squares, rectangles, trapezoids, pentagons, hexagons, all those would be examples of polygons. Okay, so polygons on the coordinate plane, there are a couple of different types of problems you might see. You might see a problem where it gives you a polygon and it might ask you what the area or the perimeter might be, okay, which really that goes along with distance that we just looked at. You may also have a problem where it would give you a couple of points and ask you what the next point might be. So that's what I want to actually look at right now, is if we had, say, 3 points of a rectangle and I asked you to find the fourth. So let's say we have these 3 points given to you. What I need to do first is identify what, let's see, that's a 5 right there. I need to figure out what those coordinates are. All right, so this coordinate right here, I'm going across 1, down 2, so that's 1, -2. This point right here would be 5, -2. And this point is 1, -4. So again, you might be given a problem like this where it says, okay, if these are 3 points of a rectangle, what would the fourth point be? Okay, well, looking at a rectangle, it's kind of easy just to kind of eyeball it and figure out where it would be. If I were to draw the lines in to see where my rectangle would be, I can see it would be right here. Okay, so the coordinates of that point would be at 5, -4. And I want you to notice the points that I've got. So what I have here, my x coordinates, I have a 1 and a 1, a 5 and another 5. And then if I look at my, let's see, my y coordinates, I have a -2 and a -2, a -4 and a -4. So what you'll notice about having a rectangle on a coordinate plane is that you're going to have 2 pairs of the same x coordinates and then 2 pairs of the same y coordinates. Okay, so just a thing to keep in mind. All right, let's say we had another one here, and this one I'm going to put into 2 quadrants. So if these were the 3 points that you were given and I said, okay, find the coordinates of the fourth point, again, you could either like eyeball it, that's not the mathy term, but you can kind of see where it would be, because you know that on a rectangle, it has 2 pairs of parallel congruent sides, so you can see that it would be here. Or you can look at the points that you're given. So for instance, this point right here would have been -1, -1. This point would have been, let's see, that was 1, 2, 3, -3, -1. And this point was -1, 3. Okay, so as I pointed out with the first rectangle, anytime you have a rectangle, you're going to have 2 pairs of x coordinates and 2 pairs of y coordinates. So if I notice, I've got on my x coordinates, I have a -1, another -1, and -3. So the next one also will have to start with -3 as the x coordinate. And then for my y coordinates, I have 3, -1, -1, and so that means I need another 3. And that gives me our 2 pairs of x's and 2 pairs of y's. Okay, just a minute. If I gave you just the points and did not actually give you the coordinate plane, you still should be able to figure out what the fourth ordered pair would have to be in order to make a rectangle. So let's say I had, these 3 ordered pairs here. Okay, this is 2 separate problems. I'll label this problem number 1, problem number 2. So looking at problem number 1, if these were 3 of the coordinates, they make up the corners of a rectangle or vertices of a rectangle, and I asked you what the fourth coordinate would have to be. Again, you've got 2 pairs of x coordinates, 2 pairs of y coordinates. So I notice on my x's I have 4, 5, 5. So I have 2 5s, that means I need another 4. Okay. And then for my y coordinates, I have a -2, another -2, an 8, and that means my next one would have to be 8. So the last order pair here would be 4, 8 in order to make a rectangle. All right, if I had the second problem here, -6, 10, -6, 0, 4, 0, my last ordered pair would have to be, hopefully you said 4, -10. Okay, and the reason, again, my x coordinates, I have 2 pairs, so -6, -6, 4, and 4. And my y's also have to have 2 pairs, so -10, 0, 0, -10. So it's 2 -10s and 2 zeros. All right, so I said this is going to be polygons in the coordinate plane. We really just focused on rectangles, which is mainly what you will see. Hopefully that helps you guys, and if not, as always, either pop into one of my Zoom sessions Tuesday through Thursday, or feel free to shoot me an email. And hopefully you guys are doing well, and I'll talk to y'all later. Bye.